to the country, gonna eat a lot of peaches. That's right, we're gonna go to the country and eat some peaches. So example 5 is looking at an issue of how do we get peaches from the grove to the factory, because that's what we want to be able to solve out, and the song by the presidents of the United States talks just about this. So how do we get these peaches to the factory so the man can put them in the can? That's what we're trying to solve right here. All right, so this is linear program example 5. So first, let us go ahead and define our variables. The way we're going to do that is we're going to draw a little thing here where we have Mount Dora, which is our orchard, and we have peaches there. We have bushels of peaches there, and we need to ship these peaches to different factories or different processing plants. So we could ship it to Ocala, we could ship it to Orlando, or we could ship them to Leesburg. So these are the 3 options that we have. So we're going to call this first option X1, the second X2, and the third X3. That is the number of bushels that we ship from Mount Dora to Ocala. Well, we also have bushels in Eustis, and we can ship them to the same 3 locations. So we'll call this X4, the number of bushels shipping from Eustis to Ocala, this X5, and this X6. So those are 3 bushels. Now we have the last one where we are getting stuff from Claremont. So the number of bushels we send from Claremont to Ocala would be X7, Claremont to Orlando, X8, and Claremont to Leesburg, X9. So we have 9 different variables, each of them representing the number of bushels that we send from a given grove to a processing plant. So those are our variables. Now let's define our objective. So our objective is to minimize bushel miles. That is, minimize the number of miles that each bushel needs to travel. Well, to do this, this is equal to, well, we were given the distance between Mount Dora and Ocala, so this is going to be just 21 times x1 plus 50 times x2 plus 40 times x3. So our objective now, you'd write out, is to minimize bushel miles, which is 21 x1 plus 50 x2 plus 40 x3, because that's 21 miles from Mount Dora to Ocala, and we multiply that by the number of bushels that we send in order to get bushel miles. Plus, now we keep going, 35x, this should be 3 right there, so this should be x4, plus 30 x5, plus 22 x6, and now from Claremont to the different processing plants, 55 x7, plus 20 x8, plus 25 x9. So there we have our objective. Now we need to think of our constraints. Okay, so the first constraint that we have is that in Mount Dora we have 275,000 bushels. So the number that we ship away from Mount Dora needs to equal the number of bushels and the number of peaches or citrus that we have in Mount Dora. So that's x1 plus x2 plus x3. So that's the amount we ship from Mount Dora to each of the different locations need to equal 275,000, or the number of bushels that we actually have in Mount Dora. The second constraint is going to deal with Eustis. So x4 plus x5 plus x6 is equal to 400,000, the number of bushels we start with in Eustis. And the third constraint is for Claremont. x7 plus x8 plus x9 is equal to 300,000 for Claremont. All right, so now we've shipped out all of our bushels with these 3 constraints. The next 3 constraints deal with the capacity at each processing plant. So if we look at our variables, those that come to Ocala is x1, x4, and x7. So x1 plus x4 plus x7 is the number of bushels that Ocala receives from the 3 different groves. And Ocala has a capacity of 200,000, so that needs to be less than or equal to 200,000. The 5th constraint deals with Orlando. Orlando is getting x2 from Dora, x5 from Eustace, and x8 from Claremont. So x2 plus x5 plus x8 needs to be less than or equal to 600,000. And our last constraint deals with Leesburg. So that's going to be x3 plus x6 plus x9 is less than or equal to 225,000. And there is our linear program. We defined our variables, we identified our objective function to minimize the bushel miles, and we have these 3 constraints, which we can think of as our supply constraints. We need to ship out all the bushels that we have in the orchard, and this is our processing constraint that we need to make sure that we are below the capacity of each processing plant.